Time series forecasting. Step 1. Plot the time series. Join the points together with straight lines, point to point. Step 2. Work out your moving averages and plot the moving averages, but do not join them together. You draw a trend line through the moving average points, and the trend line is a line of best fit, either by eye or by using the regression equation. The trend line only goes through the moving average points. So at this stage, ignore the original time series that you plotted in step 1. Just focus on the moving average points that you plotted in step 2. Step 3, work out the required residuals and use these to work out the seasonal effect. Step 4, to work out a forecast, add the trend value from your trend line to the seasonal effect that you've worked out in step 3. You need to memorize all of these 4 steps to do a forecast. A theatre holds a maximum of 600 people. Attendance for 3 weeks of a new play is shown below in this table. So you have the weeks, so week 1, week 2, week 3. You have the day of the week that the theatre opens, Tuesday, Wednesday, Thursday, Friday, Saturday, Tuesday, Wednesday, etc. You have the attendance, and then you have moving averages. For this table, we should work out a something point moving average because. So we need a reason why. Have a look at the repetition in the time scale. So we've got Tuesday, Wednesday, Thursday, Friday, Saturday, and then you find those days repeat again, and they repeat again. And clearly from this, we can see we have a 1, 2, 3, 4, 5 point moving average, because the days Tuesday, Wednesday, Thursday, Friday, Saturday repeat. Complete the table. So we have a missing value here, and we have a missing value here, and you may have noticed that there's 2 gaps here, but there's 4 on this side. So we should have some moving average values calculated here. So we need to work out these 4 missing values. To work out this moving average value, using 5 data points from this row, and the moving average value is always in the center, which means we need to use these 5 data values. If we work out their average, we'll get the moving average value here. So we have 230, that value there, plus 320, plus 430, plus 228, plus 209 over 5, because there's 5 values, it's a 5-point moving average. As you can see, there are no decimal values for the moving averages, so we should round this to an appropriate degree of accuracy, which is just following the rest of the values in the table, 283. So this value here is 283. And if we do the same for this moving average value here, we take 5 values from above, 1, 2, 3, 4, 5, and the moving average being in the center of these 5, adding them together, dividing by 5, 340. So this value here, 340. And the last moving average value here, again, if we add up the data values, these 5 here, all the way up to 504, divide by 5, it's a 5-point moving average, so that gives 346. 346. Okay, that's the moving average values calculated. Now we have to see how to work out this missing data value here. Now that value would have been used to work out this moving average value here, and this one here, and here, and here. So we can use any of these moving average values to work out what this value here would have been. Now we know that 209 plus 250 plus the missing value there plus 470 plus 254, all of those added and divided by 5, because it's a 5-point moving average, would give 306. So as you can see, this is a simple rearrangement to work out the missing value here. So if you take 306 and multiply it by 5, that should give you the sum of all these values here. And then from there you can work out what that missing value was. So this is 306 times 5 to give you 1530. And from this, if I subtract each of these values, it will leave the missing value here. So minus 209, minus 250, minus 470, minus 254, 347. So that's what the value here would have been, 347. There we go, we have a complete table now. We now move on to plotting the data on a graph. So we have attendance on the vertical axis, and as you can see, we're not starting from 0, you don't have to. And you have the time scale on the horizontal axis. Time always goes on the horizontal axis with time series. So this is week 1, week 2, week 3, and week 4. This is the part we're going to use for forecasting. So make sure when you're doing a graph, you plot your time series, and then you add additional space for your forecasting. Typical exam questions include partially completed graphs like this. So some of the points have already been plotted for you, and you have to plot the additional points, the remaining ones, and then join the graph, point to point together. So that's the next point there, here, and then make a line from the previous one to that point there. Okay, so we're just completing our time series graphically here. A severe storm occurred before one of the performances. Which day was it? So if a severe storm occurred, then you would expect attendance to be lower than expected. So going back to our graph, week 1, if you look at the attendance, it's increasing day after day, and it peaks on Saturday, Tuesday being the lowest. Week 2, Tuesday starts off fairly low, but Wednesday's even lower, and then after that it starts to increase But that Wednesday value there looks suspicious because in the previous week it was in between the Tuesday and the Thursday value. But this time it's lower. It's much lower, so that's a suspicious value there. The remaining days, the attendance looks as expected. It's increasing. Week 3 is similar to week 1. Attendance increases day after day. So the suspicious point in all of this is Wednesday of week 2. That's where the attendance was lower than expected. We expect the value to be around here, but in fact it's quite a bit lower. So this is the day and the week in which the storm occurred. Okay, we're moving on to plotting the moving averages. So just plot the points, but do not join the points together. Once you've plotted the moving average points, do a line of best fit by eye through the moving averages. Okay, just the moving averages. This is called the trend line. Here is the first moving average point plotted, right there. The reason it's here is because the first moving average value coincides with Thursday of week 1. This graph shows, well, this table shows the original data, and as you can see, the first moving average value there coincides with Thursday of week 1. That's the reason for placing that value on the graph where it is. Okay, and then plot the second moving average value, the third one, and so on. That's all of the moving average values plotted. And now we're going to draw a line of best fit by eye. Make sure your line extends the full width of the graph. This line is called a trend line. We can see from this trend line that we have an upward linear trend in the attendance figures. So this is the underlying pattern in the data. So a moving average, as you can see from these points, is used to smooth out this jagged behavior on the graph. And this smoothed out behavior here clearly shows the underlying trend in the data. So with this data we can see an upward linear trend. When you extend the trend line into the future, you have to be careful because this linear trend will not continue forever. As the attendance figures increase, we know that the theatre has a maximum seating capacity of 600. So once this trend line reaches 600, it has to level off because it would be nonsense to increase it above 600 when 600 is the maximum capacity of the theatre. Now we're going to do a forecast for the attendance for Tuesday of week 4. So using the formula, the forecast will be equal to trend plus seasonal effect. So the trend value comes from the trend line, and that's the value for Tuesday of week 4. So let's focus on this first. So what is the value for Tuesday of week 4? Here's the Tuesday of week 4. And if we follow this up to our graph here, when it meets the trend line and then go across, we need to know what this value here is. Read the scale here carefully. So that's 350, that's 360. So that value there is 360. plus the seasonal effect. We're specifically looking at Tuesday, so work out the average residual for all the Tuesdays on the graph. A residual is the difference between the actual data value and the estimated data value. The actual value for these Tuesdays is recorded in the table, and the estimated value will come from the trend line. On the graph, identify all of the Tuesday values that are within the moving average range. That's the first moving average value, and this is the last one. The Tuesdays that are within this range on the time scale here are this Tuesday here and this Tuesday here. This Tuesday here can be safely ignored. If it was included in the calculation, you're not going to lose any marks in the exam, but it's easier to just stick to these two Tuesday values because they are within the range of our moving average points. So let's work out the residual, which is the difference between the actual data value and what the trend line gives for this Tuesday and for this Tuesday. So the difference between the actual value and what the trend line gives. So we're looking at Tuesday of week 2 and Tuesday of week 3. Looking at the table here, the Tuesday of week 2 has a value of 228. So this value here is 228. And the Tuesday of week 3 has a value of 254. So this value here is 254. This is more accurate than trying to work out what this value here is from the time, from the attendance scale here. So we have the actual values for our Tuesdays. Now we need the estimated values, which are these values here. So on the actual line there, what's the value there on that scale? And what's the value here on that line by reading off the scale here? So for this point here, if you go across, that's about 292. So that's the estimated value there, 292. And this value here is about 325. Now we can work out the residuals. Remember, a residual is the actual value minus the estimated value. So for the first point, actual 228 minus estimated 292. That gives you a value of minus 64. So that's our first residual, minus 64. If we do the same with the second Tuesday here, so actual 254 minus the estimated 325, and that gives a residual of minus 71. So now we need the average of these two residuals. There, average of Tuesday residuals. So if we add up these two values, there's two of them, so we're going to divide by 2. So minus 64 add minus 71 divided by 2. Minus 64 add minus 71. So just add them together, divide by 2, and that gives us an average residual of minus 67.5. So the average residual here is minus 67.5. So why is this value negative? And why are these residuals negative values? Well, if your data points are below the trend line, you always get negative residuals, and if the data points are above the trend line, you will get positive residuals. So now we can do the forecast, so 360 plus minus 67.5. 360 plus minus 67.5. 292.5. So if I just round that to three significant figures, the forecast is 293. And because this figure represents attendance, using whole numbers for your final answer is sensible. So just to go over the basic points here, your step 1, plot the time series and join the points with straight lines point to point. Step 2, calculate a suitable moving average, so work out is it a 2-point, a 3-point, 4-point, etc. moving average. Plot the moving average points, and then for these moving average points do a line of best fit. So that's a single line going through all of the moving average points. Step 3, do your forecast. So use the trend, and that comes from the line of best fit, and your seasonal effect, which is just an average residual.